Welcome back. So in this video, we're going to talk about the notions of functions being increasing and decreasing, and what those look like in graphs, and how we can use those to try and tell apart some various graphs that might look similar or we might not immediately be able to recognize. So what does it mean for a function to be increasing? Okay. Again, it's always helpful to frame things about functions in terms of input and output. In this case, being increasing means that if you increase the input, it increases the output. Okay. Which means that as you move from left to right, the y value goes up. So something like that, something like this, something like this. Those would all be increasing. Okay. Broadly speaking, increasing means it goes that direction as you move left to right. Decreasing is the opposite. It means that as you increase the input, the output actually gets smaller. So it's something like that, or something like this, or something like this. Okay. Decreasing means broadly that it's moving in this direction. Now, I want to point out that there's a different way to think about what increasing and decreasing mean that's sometimes helpful, which is that increasing means the input and output move in the same direction, and decreasing means that the input and output move in opposite directions. Why is this helpful? Well, this is helpful because you don't always think of the input as going up. Sometimes you want to think about the input going down. And so this tells you that for an increasing function, if you decrease the input, you also decrease the output. Or, if you increase the input, you increase the output. Whereas for a decreasing function, that's reversed. If you increase the input, you decrease the output. Or, if you decrease the input, you increase the output. And so this way doesn't sort of bias it towards thinking left to right. You can think about your function either direction. And as we'll see later, that'll end up being useful. I also want to point out, this connects to our discussion about slopes of lines and what different lines look like, because positively sloped lines are the ones that lean this direction, and so positively sloped lines correspond to increasing functions. Negatively sloped lines are the ones that lean this way. They correspond to decreasing functions. So if this seems a little bit familiar, it should be. So first of all, if we want to think about this problem in terms of increasing and decreasing, we should look at this graph and decide which one it is. And this is increasing. As the input gets bigger, the output gets bigger, meaning the input and output move in the same direction. So the graphed function is increasing. Okay. The graphed function's increasing. What about f and g? Well, how do I decide if something is increasing or decreasing? By looking at the equation. The answer is that I really want to look at some specific inputs. So, for example, I might take f of 2 and f of 4. I just chose 2 and 4 at random. You can choose any two inputs you want. Okay. If the function's increasing, which of these should be bigger? That's right. If the function's increasing, f of 4 should be bigger. Why? Because we increased the input from 2 to 4, so we should increase the output. So what is f of 2? Well, f of 2 is 2 squared. That's 4. What is f of 4? It's 2 to the 4th. That's 16. And so the thing I'm seeing here is that when I increased the input from 2 to 4, I also increased the output from 4 to 16. This is all consistent with the statement that the graphed function's increasing. Now I can do exactly the same thing, g of 2, g of 4. Okay, g of 2 is 2 to the minus 2, so it is 1/4. G of 4 is 2 to the minus 4th, so it is 1/16. So as I increased the input, I went from 1/4 to 1/16. I have to think for a second, which of these is bigger? Bigger denominator means smaller, right? So in fact, 1/4 is bigger. So as the input got bigger, the output actually got smaller. And so in the case of G, the input and the output moved in opposite directions. And so this opposite direction movement, that's what I mean by decreasing. As I increased the input, the output decreased. And so that means this function can't be G. Here's one more example of that. So here I have a function, and I want to emphasize this function's negative, but it's still increasing. It's still moving in this direction. Okay. So this function is increasing. The outputs of the graph function are all negative, but it's still increasing because the graph is still moving in this direction. Okay. But it takes a little care to think about what it means for a function whose values are negative to be getting bigger. Because for negative numbers, bigger means closer to 0. And so remember, for example, negative 4 is definitely bigger than negative 7. Even though 4 is smaller than 7. So we have to think about the way the number line lays out these numbers. And so I'll go ahead and calculate f of 2 and f of 4, and g of 2 and g of 4. Okay, so f of 2 is minus 4. F of 4 is minus 16. Okay. Do note, when I have a minus 2 to the x, the power comes before the minus. And so this really is minus 16, not plus 16. Because really, when you see minus 2 to the x, the order of operations means this is minus 2 to the x, not minus 2 to the x. Remember, we don't read left to right, we use the order of operations, and powers comes before subtraction. On the other hand, when I look at g of 2, that's negative 2 to the minus 2, so that's minus a fourth. And g of 4, that's minus a 16th. So now I have to look at this again. As I increase the input from 2 to 4, what happened? The output, in fact, decreased from negative 4 to negative 16. So I'm putting the arrow in the direction of increasing, if you're trying to follow what's happening with the arrow. So negative 4 is bigger than negative 16, so I put the arrow that way, but 4 is bigger than 2, so I put the arrow that way. And so in this case, the input and output are moving in opposite directions. Okay. In this case, as the input increases from 2 to 4, the output goes from negative a fourth to negative a 16th. I have to think about this for a second. So a fourth is bigger than a 16th, which means that negative a 16th is bigger than negative a 4th, which means that the arrow goes this way. Okay. And so in this case, the input and output are moving in the same direction, which matches the graph. And so much like last time, when I go to write this up, I'm going to write something like the output of f of x decreases as the input goes from 2 to 4, but the graphed function is increasing, so the graphed function must be g of x. Okay, so as a final note, the way the homework is arranged is exactly the way that this lecture was arranged. Namely, first there's a problem and it says, hey, look at the x and y intercepts, how many of them there are, whether they're positive and negative, and use that to sort out which function is the graphed function. For the next question on the homework, it says, hey, look at where the graphed function has a positive output, where it has a negative output, and where it has an undefined output, and use that to sort out which function is the graphed function. Then there's an exercise that says, hey, look at the graph and decide if it's increasing or decreasing, and use that to sort out which function you're looking at. And then there's a final exercise where I give you 4 more of these questions, and you're free to use whichever of these methods you want. So you can look at all of them that apply. And for that exercise, and indeed any of these you see in the future, there's often going to be multiple ways to do it. So maybe you could do it with x-intercepts or positive negative input-output, or increasing, decreasing. And so there are a lot of different ways you might reason through the same thing. Now, finally, I'll note that you have access to a graphing calculator or Desmos or whatever, so of course you could do these by just graphing the two functions. But if you do that, then you're not making sure you are learning and understanding the things that we're supposed to be getting out of this exercise. So make sure you really understand and are capable of writing this kind of explanation for each of these questions. And then you'll be well prepared for the test. All right, we're going to wrap up there for today. Next time, we'll be back and we'll be talking about section 1.10 on piecewise functions. But for now, I'll see you next time.